So we're going to continue verifying trig identities. These are going to be the problems under the heading verifying trig identities 2. I'm going to do problems 1 through 6. And I'm going to jump right in and let's see what these problems have in store for us. There's nothing special about whether you pick the left or the right side. It's really just going to be a matter of what you recognize in these problems. One of the things that I recognize is I have a denominator on the left side, but I don't actually have a denominator on the right side. So I kind of want to see what happens if I can get rid of this denominator or maybe multiply through. Now, what I'm going to multiply through by is actually the conjugate. So if you remember from first semester, we have 1 minus sine x. So I am going to multiply by 1 plus sine of x. Of course, what you do to the denominator, you have to do the numerator. So numerator, I'm going to distribute. So this is going to be cosine of x plus sine x cosine x. That's the numerator. Now in the denominator, I've got 1 times 1. Then I've got 1 times negative sine, and then 1 plus sine of x. So those two are going to cancel. But what I will end up with is sine x times negative sine x. So negative sine squared x, which that denominator can be replaced with cosine squared x. So numerator has not changed yet. I'm going to get there. And that is cosine squared of x. Now, I have two fractions sitting here. So I've got cosine of x over cosine squared x, and then this part of the numerator, they're separated by addition or subtraction. So this is a separate numerator that I can split this fraction up. So I'm going to split this into cosine of x over cosine squared x plus sine x cosine x over cosine squared x. Simplify. Let's see, cosine x and over cosine squared x, that would just leave me 1 over cosine x. This cosine in the numerator will divide one of these cosines out. So that would be sine x over cosine of x. Let's see, 1 over cosine is really secant of x. Sine x over cosine of x is really tangent of x. And if I zoom out, this is exactly what I wanted to end up with on the right side. So there's my verification. Now, if you did, it is absolutely possible to turn this right side into the left side. It won't matter to me. Just make sure that you show your work so I can see the steps. All right, number 2. Number 2, I'm going to do a little differently, mostly because this cotangent squared x can be replaced with, whoops, no, wrong thing. It can be replaced with cosecant squared x minus 1 over 1 plus cosecant of x. This is probably something you may not have recognized. You can actually factor this. This is a difference of perfect squares. You've got cosecant of x squared, and then you've got 1, which is really 1 squared. So if I factor this, this would be cosecant of x plus 1 and cosecant of x minus 1 over 1 plus cosecant of x. If you recognize this factor as this denominator, go ahead and divide them out, and you are left with cosecant of x minus 1 is exactly equal to cosecant of x minus 1. All right, again, the whole point is that you only manipulate one side of the equation to turn it into the other side. Do not change both of them. All right, problem number 3. I'm just going to split this. So if you have a single denominator and you have multiple terms in your numerator, you can actually split this up into multiple fractions. So 1 over sine of x, except it would help if I actually write a separate x, minus sine x over sine of x. So 1 over sine of x is the cosecant of x. Sine x divided by sine x is just 1. And lo and behold, that is exactly what I was aiming for on the right side. As you do more of these, you get to recognize certain things that you kind of aim for. For this particular problem, I'm not exactly sure how to turn tangent 4 theta, or into this side. So I feel like I'm going to work with the right side here. I have tangent squared theta that I can factor out. So secant squared theta minus 1. So let's see, secant squared theta is one of my Pythagorean identities, and that actually can be replaced with tangent squared theta. When I multiply those together, I would get tangent theta to the 4th. Gotta be careful how I say it. And so that's going to match the left side. All right, problem number 5. Well, this isn't too terribly pretty. Let's see what we've got here. I'm actually going to try the right side here. Let's see. Cosecant of x is 1 over sine of x minus sine of x. So this is a 1 over sine of x. I keep trying to put that sine of x as 1. There we go. Minus sine squared x over sine of x. I'm just getting a common denominator there. So let's see. 1 minus sine squared. I keep trying to. Okay, now I just got to slow down. There's the x over sine of x. So let's see. That is really 1 minus sine squared of x is cosine squared x over sine of x. Let's see. So that would be, let's see, cosine of x. I'm going to split this into cosine of x times cosine of x over sine of x. I feel like somehow I have done something horribly wrong here, and I'm not liking where this is going. No, actually, I'm doing fine. I'm just not sure why I'm not liking it too much. Okay, so let's see. Cosine of x is really 1 over secant of x, and then cosine over sine is cotangent, and cotangent is 1 over tangent of x. It took me a while to get there, but I finally got there. And if you're looking at this going, hey, I could have done the left side and turned it into the right side, that's awesome. Do that. Again, left or right side won't matter. I will be looking at your individual steps to make sure they're correct. So yeah, these two sides match. Again, cosine of x is really 1 over secant of x, and cosine of x over sine of x is cotangent, and then cotangent is really can be rewritten as 1 over tangent of x. All right, last problem. Let's see what kind of mess this one turns into. Let's see here. Well, I'm going to change, I think, the right side into the left side. So let's leave that one alone. And then tangent squared x can be rewritten as secant squared x minus 1. So 1 minus secant squared x, distribute, that's going to become a plus 1. So 2 minus secant squared x, 2 minus secant squared x. All right, so those are the 6 questions for verifying trig identities number 2. If you have any questions or concerns, please let me know. And if you try one of the problems a different way and you just want to double check that your work is good, feel free to take a picture of it, send it to me, and I'll double check it for you.